Hi, so myself Dr. P. Manikandan, working as an associate professor in the Department of Aeronautical Engineering. So today we are going to see the topic of fatigue strength. So already we have seen that what is the effect of inertia and the stresses, impact strength due to impact stresses due to axial load, bending load, and torsional loads. So effect of inertia. So today we are already the last class we considered fatigue strength introduction. So today we are going to explain about SN diagram, low cycle fatigue, high cycle fatigue, and what is the endurance limit, and what are the modifying factors, right, for the fatigue life. So fatigue strength, the stress that can be withstood for a specific number of cycles is called fatigue strength of material. So any material will be undergone the cyclic stress. So it will be for for the entire lifetime of its application. So when it is going to the cyclic stress, until how many number of cycles? So one cycle means from always the stress will be varying with the time, stress amplitudes. So when you will be having the cyclic stress, right? So and moreover, it is not. It is cyclic stress also multiple types will be there. So full and full, maximum tensile or maximum and minimum is both are tensile. So maximum will be tensile and the minimum will be zero level stress. So in that as amplitude stress, everything will be seen in detail. So now this it's one cycle. One cycle stress will be how many number of cycles the entire component will withstand. That is that your fatigue strength of the material. So how we can check this through the SN diagram, right? So this is the SN diagram. So as I said, you will be having a stress will be varying with time, and so you will be having multiple stresses. So that types of cyclic loading will be there. So this case, you will be having that maximum as your also tensile strength, your minimum also is a tensile strength. So both are in positive. So similarly, so you'll be having a cyclic stress, you'll be having the maximum will be your tensile and the minimum will be your zero level of stress. So similarly, it's vice versa for the compression also. Maximum and the minimum will be compression, and you'll be having the maximum stress is zero level stress and minimum will be the compressive strength. So, but in any component or any in practical application, not only that only one type of cyclic loading, it will be multiple types of, it's a combined loading only. So it will be experiencing the cyclic, both will be tensile, and it will be experiencing the bending, it will be experiencing the compression strength. So everything, it's like a combined loading. So when the combined loading is acting, then for that case also we'll be having a rules Soderberg relation and a Goodman relation. So that all we will see in detail. So now basically how we are calculating this fatigue limit or the endurance limit, endurance strength will be by using the SN curve. So SN curve, how it is happening means that the curve will be stress amplitude versus the number of cycles. So as I said, for one cycle, one left. For aircraft, if you are taking means you can consider that one for the cycle of the aircraft is from takeoff to landing. This is will be like one completed load cycles. So from the takeoff to landing, again from the takeoff to landing. So this will be like this for one aircraft. How many flying hours it can? We can decide. This is the flying hours. This is the total flying hours of the one aircraft can fly. So that how we are deciding means by using its fatigue strength only. So once the aircraft completed its flying hours, entire flying hours, then it will be that will be that. After that, that aircraft we cannot use it. So that is that your flying hours, and how like that only the fatigue limit we are deciding how much the maximum stress it can withstand, how much the load cycles the component or the product will withstand. So that is that your fatigue limit. So how we are calculating this? So stress amplitude is a cyclic fatigue. So what is fatigue limit of a material? The fatigue limit or endurance limit is the stress level below which an infinite number of loading cycles can be applied to a material causing fatigue failure. So the fatigue failure when it will occur means it no need to, usually the material failure will occur. We know that when it is reaching the ultimate strength or that ultimate stress once it is reaches, then or the maximum yielding point once it is reaches, then the material will fail. But in fatigue failure will be entirely different. So fatigue failure anytime it can appear, but it will be for the low level of stress also. It no need to be reach the ultimate strength or ultimate stress. Less than that or lower stress level also, the failure will occur. That also the failure will be, it will be like a catastrophic failure. It will be almost similar with your brittle material, but the neck formation will not be there, and it will be starts with three stages. One is crack. First it will be initiate, and the crack will be propagate, then the failure will occur. So that one we will see in detail. So now SN curve, how we are drawing means, so SN curve by using that rotating beam testing is a one test show here. So this is that a sample, you are having a sample here. So this sample will be located. So as I said, when any component or any material will be undergone the combined loading, and it will be experiencing that cyclic stress, or it will be experiencing the tensile stress, full and full tensile stress. It will be experiencing that full and full compression strength. So like that, it will be vary. So when it is experiencing that some kind of bending, so the time rotating beam testing machine, this is RR Moore rotating beam testing. So what we will do here, you can see the motor. So the motor will be rotating it. So it will be, the sample will be rotate. It will be having the rotation. Then the load will be acting here. So what will happen? So this when this load is appearing, so when for this condition, so you know that it will be experiencing the bending. So it will be experiencing the, so the top surface will be undergone the compression, and bottom surface will be undergone the tension, right? So it is a rotation. Under rotation, this component, this specimen is entirely rotation. So when it is going for the next rotation, what will happen? This bottom will be going up, this up will be coming down. So what will experience? It will be experiencing the reverse bending, right? Then that is that your one cyclic stress, right? So first it will be from the zero. From the zero, due to the load, it will be experiencing the top surface will be experiencing the compression, and bottom surface will be experiencing the tension, right? So that will be one cycle. Then next it will be coming to that again when it is having a rotation. So which will be experienced compression. Now that will be experienced, that part will be experiencing the tensile. Then that upon another part will be same vice versa, which will be experiencing the tensile, that will be experiencing the compression. So during that time again that another one cycle. So now the tension and the compression will be experiencing continuously. So this is that your one cycle of tension, then again next compression, then similarly we'll be going for the multiple cycles. So this will be reference, the stress will be varying with reference to respect to time, right? So now this, how many cycles like this specimen can withstand. So that is that your SN diagram. So that where we will be doing, we will be recording each and every one cycles. So that only we will be taking this a number of load cycles. So you can see here now the SN diagram will understand. So cycle to failure, right? So the exercises will be cyclic to failure. So cycle to failure means that is that your number of cycles in the scale of log scale. So 10 to the power 2, 10 square, 10, 3, 10. This multiple cycles will be experiencing. Then it will be your stress amplitude. So now for that, whatever that load you are getting, that for the initially you will be experiencing the high stress. So you will be applying the high stress. Then for that you will be getting the point. And similarly, when for the next each and every point you will be experiencing the stress level will be, you will be reducing it, and continuously you will be doing this test. So the continuous recording of the number of cycles, similarly the values of the stress will be marked. Then you will be draw a mean curve for this your received stress levels. So for that only your SN curve. So now you can see here. So now any point, right, for any stress, if I'm taking this, then I will get to know for this stress level, this component, this material will be withstand up to this much level of 10 to the power 5. If I some example, if I'm taking 10 to the power 5, so 10 to the power 5 cycles it can go for this stress level, whatever the stress we are getting. If you are this, you can see that again. So when you are applying the high stress or high load will be high, or stress will be high, then your life cycles will be less, right? When you are applying the low stress level, then you can see here your life cycles will be more. So the number of stress cycles will be more. This is that your SN diagram will give the data. So this SN diagram for the each and every material, each and every component, it will be vary, right? And for the it will be experiencing with the manufacturing method also. In any same, for example, aluminum alloys, when it is having the different manufacturing methods, so for that also it will be slightly vary. So SN curve will be vary with materials to material. For ferrous material, it will be acted differently. For non-ferrous materials, it will be differently. So for ferrous materials such as steels, so you can see here the second diagram. So the stress and that same number of cycles. So you can see the for the ferrous metal, for example mild steel. So for that, after this formation, what will happen? This is that we'll call this a knee formation. So after this formation, it doesn't matter that how many cycles, the number of cycles, so how many cycles it will go, it will not fail. It will be go, it will be following the same trend only. So it will not fail. Then what? It's like an infinite number of cycles. So what we will do, where this knee formation is happening, then after that, where it is there is no variation, then that point they will be taking as a endurance limit for the your mild steel. So similarly for the aluminum alloy, you can see here. So this will be again there is no knee formation or that. It will be keep on reducing. So for that, they will be fixing one point and it will be deciding that as a number of cycles. So generally, it is 5 into 10 to the power 8. They will decide for the aluminum alloys. So a graph of failure stress against number of repetitions of the stress typically is one form as shown in as a SN diagram. So for some materials such as mild steel, the curve usually known as SN curve is asymptotic to a certain minimum value. So that's what it is, very close. It's not closing to the minimum value. So after that, when you are increasing the multiple number of cycles also, the failure will not occur. So from that point, we are taking that as a endurance limit, right? So endurance limit is some materials such as mild steel possess a stress level that can be withstood for an indefinite number of cycles. The stress is known as the endurance limit of a material. So the SN diagram is a graphical representation of stress amplitude versus the number of stress cycles. So before the fatigue on similar paper or log. So it will be SN curve only. So the x-axis will be your number of cycles in a logarithmic scale, and your y-axis will be your stress amplitude. So for the different stress, how the material is behaving, so that each and every thing will be recording. So one example, I show that RR Murray bending test, rotating beam test. The first test is made. See, the first test is made at a stress that is somewhat under the ultimate strength of a material. So first test will be maximum stress. That only we said. So first test will be the maximum stress. So number of cycles. So first test will be the stress will be high. Then what will happen? So and somewhat under the ultimate stress. The second test is made at a stress that is less than that used in the first. So keep on reducing. We are keeping on applying the reduced stress. Then you'll be having that reduced level of stress. So when you are having that multiple points, then the mean value will be taking, and the mean line we are drawing. That is at your SN curve. So this is that RR Murray rotating beam test. So each and every cycle it will be recorded. So how many number of cycles is there? So that will be continuously plotting in the graph. That is your SN curve. So this is that for mild steel. So when you are having multiple stresses, that only said. So when you are having that first ultimate strength, then you will apply that less than that ultimate strength stress. Then after that, keep on. You will reduce the stresses levels. Keep on. We will be reducing. Then we will be recording. And parallelly, we will be recording the continuous values. So then the mean value you are drawing, that is at your SN curve. So for the mild steel, I said for the ferrous materials, after some point, once it reaches its knee point, then further it will not, how many cycles it is applied, this will not fail. This will be, if it continues the same trend only. So for that only, this point we will be taking as a endurance limit. So for the aluminum, similarly, it will be similar way only. So 5 into 10 to the power 8, they will be taking generally for the aluminum, for the non-ferrous metals. So main steps in the SN life estimation procedure, that only. So what I explained. So determination of fatigue life in terms of number of cycles, history repetition, the number of cycles to failure, N. So the procedure has to be repeated several times if multiple stress concentrations or critical locations are found in a component or structure. So failure of a material due to failure may be viewed at a microscopic level in three steps. So that is that these three level of steps only the crack fatigue will be failed. So first level is initiate the crack initiation. Then the second one will be crack propagation. Right, it will be further, it will be propagate. Then third one is failure. So now any one material, it will be if it will be experiencing any stress levels. So you know that stress will be that resistive force internally. The material will be having that it will be resisting the forces, right? So it will be resisting forces will be acting. This resisting force divided by the area only your stress. Right now the resisting force you can see here the stress will be traveling in a straight line. So now when you are having any scratches or any undulations or any surface um, cracks or surface scratches if it is there. So what will happen? Whatever the stress is traveling here, the straight line it will be experiencing here some. It will be experiencing the stress concentration. Right. So now this area you will be experiencing the more stresses. So what will happen then? If the crack is formed, then at the end your stress concentration will be more. So this will be further. It will be further crack. Will be propagate. Right. So once again, the third stage will be failure. So that is that failure how it will be occur in a three stages: crack initiation, crack propagation, and failure. So the basic factors causing fatigue failure, the maximum tensile stress, sufficiently high value, a large amount of variation of fluctuation in the applied stresses, a sufficiently large number of cycles of the applied stresses, then additional factors causing fatigue failure is stress concentration. So due to the scratches, so how these factors and all affecting the creating or will be causing the fatigue failure, that and all we will explain in next class. So stress concentration, residual stress, what is residual stress, combined stress, then corrosion due to the temperature variation and due to the overload conditions and metallurgical structure and cyclic stress state, geometry, so how the material type is affecting residual stress, size and distribution of internal defects, environment conditions, temperatures, and factors that are affecting stress like the cyclic stress state, geometry, and the material type. So similarly, what is low cycle fatigue, high cycle fatigue means? So in a general word, I tell that low cycle fatigue you will be always having the high stresses. So when you are having the high stresses, right? So here you will be having 10. Right. So when you are applying that high stress level, then that will be your low cycle fatigue. So that is that you are for generally it will be 10 to the power 3 cycles. So in low cycle fatigue, you will apply the high stress. So then default the number of cycles will be less. In high cycle fatigue means the stress level will be less low, so that you will be having the material can withstand for the more number of cycles. So that is that your low cycle fatigue and high cycle fatigue. Low cycle fatigue occurs under high stress and relatively few cycles. So example, engine pylons or wing fuselage attachment where you will be experiencing the maximum stress or more stresses that will be under during heavy maneuver conditions, emergency. So lug assembly, when we are attaching the wing in the fuselage, so the lug assembly will be experiencing the more stresses. So these parts may deform plastically during rare extreme maneuvers, so hard landing or emergency descent. So high cycle fatigue occurs under lower stress but over a high number of cycles. So example, fuselage skin panels near windows experiencing repeated pressurization cycles. So when the aircraft before the takeoff and after landing, so you will be doing the pressurization of the cabin and similarly depressurization of the cabin. So while you are doing the depressurization and depressurization, we know that the circumferential stress will act. That is that hoop stress. So due to that, it will be experiencing the tension and compression. So skin panel. So every flight pressurizes and depressurizes the cabin, causing fluctuating tensile stress on the fuselage skin. So a classic source of high cycle fatigue cracks. So it will be, but it will be the stress will be low level. It will be continuously. It will be experiencing for the. It will be withstand for the high number of cycles. That is the your high cycle fatigue. right? And the types of fatigue and how that other factors are affecting the fatigue life, and what is endurance limit modifying factors. So how that modifying factors is acting here, and this Goodman relationships, so remaining that, and everything will be seen next lecture. So thank you. So these are the some references. So like, you can refer that Maxon book also. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.